Welcome back to the next video. In the previous one, we went through all the four types of Wittig reactions. It was very complicated, so in this one, we're going to create a little summary sheet so that we have everything on one page and it doesn't seem as crazy. Now, since a large part of the previous video focused on how to make the ilids we need in Wittig, that part is going to be left off the summary sheet and can be found in the previous videos. This summary sheet is mainly concerned with how to actually do the Wittig reaction. Okay? So, we have four types of Wittigs that we went to. We're going to divide this up in terms of the type of ilids they used. So, if we use an unstabilized ilid, which is the first reaction we went to. So I'm going to call it kind of the basic Wittig reaction. The ilid we used is this one. The carbon chain itself does not have an electron withdrawing group there. And we just use PPH3. And again, sometimes it could be written like this. That's the same thing. That right there is the formula for phenyl, and we have three of them. So they may write it as either one. Again, the ilid in this case does not have an electron withdrawing group. We react it with an aldehyde or a ketone, so at random I'll pick this one. Like that. And how do we connect it? We connect the carbon double bonded to that phosphorus, and we connect it to the carbon of that carbonyl. So it's going to look like this. Benzene, this compound carbon, so we call this 5, 4. 4 is going to be double bonded. And at the opposite end of 4, what carbon is double bonded to is carbon 1. Now, the basic Wittig reaction is going to create the Z isomer, which means both of those carbon chains should be on the same side of the double bond. So carbon 1 is here, 2 is going to go in that direction, and 2 is connected to 3. The Z isomer. So that's the first of the Wittig reactions we learned. Again, to actually make the ilid, you can go back into the previous video. Now, still keeping with the same theme of the unstabilized ilid, we're going to still use an unstabilized one, but we're going to add something to it. This is the second one we learned. In this case, we're going to use the extra base modification. With the extra base modification, we keep everything the same. It's still an unstabilized ilid. The ilid itself does not have an electron withdrawing group, but we're going to add an extra base, usually PHLi, a phenyl, which is a benzene, bounded to lithium. We're gonna connect it the same way. So benzene, carbon chain, 5 and 4. 4 is double bonded to an O, so this one is still going to be double bonded. And the other end of that double bond is going to be carbon 1. Carbon double bonded to the phosphorus takes the place of the O. But this modification gives us the opposite of the first one. Instead of the Z isomer, we get the E isomer. And so we get it so that the two chains are on the opposite side of the double bond. So our major product is the E isomer. Those are the two types of Wittigs when it comes to the unstabilized ylids. What about the stabilized ones? So now we're heading into the stabilized territory. So if you have a stabilized ylid, there are two types. The first one is called the HWE modification. The ylid is now different. So the ylid is going to look kind of like this. It's going to have an electron withdrawing group. And a lot of the times you may see it written like this. And that's when we wrote it out like this. Same thing. In this case, the phosphorus is going to have that negative on it. Okay? So we can write it either way, whichever way is you're comfortable with. Just keep in mind that they can write it in two different ways. Okay? I'm going to keep it like this for simplicity's sake because you can find the other version on the previous video, and I want to keep this all on one page so you guys can have like an easy screenshot for the future. So in this case, our ylid is now resonance stabilized. It's got an electron withdrawing group. That's why we need to rewrite it in this fashion. So we have our ylid. Again, we can use a carbonyl. Let's use a different one this time. Let's say it's this one. Again, aldehyde or ketones. So what's the number? Let's call this still 1, 2, 3, 4, 5. I'm going to redraw this. Three is double bonded. So it's still going to stay double bonded, but instead of the O, the carbon double bond here is going to take its place. So 4. Now, E or Z, that's the question. With the HWE modification, we get the E isomer. So 4 is going to be connected to 5 so that the chains are in opposite directions. 5. And 5 is part of the benzene. Like this. E being my major product. The very last reaction of Wittig is same idea. It's a stabilized ylid. But instead of using this HWE modification, we use a slightly different one. It's very similar. This one. And in the case of the ylid, it's also a little different. It still should have a withdrawing group. It's still got to be a resonance stabilized or electron withdrawing group ylid. But it's going to be written like this. Like that. F3CH2CO parentheses 2 and that. But once you have that, we do it the exact same way. Let's say this would be my carbonyl. In this case, it's an aldehyde. Remember, Wittig only works with ketones and aldehydes, not every type of carbonyl compound like carboxylic acids or esters. So we would draw this out. 3, 2, 1. 1 was double bonded. It will stay double bonded. And at the other end, instead of an oxygen, it's going to be carbon 4. And in this case, instead of the E isomer, we get the Z isomer. So 5 would be coming down, and we get the rest of the benzene. So Z is the major product here. So that's the summary of the 4 types of Wittig reactions. And so I know it's a little bit complicated. In the previous video, we went over both how to do the Wittig and how to make the ylids. In this one, I kept it mainly with the how to actually do the Wittig reaction, because you'll see that much more than you would see how to make the ylid, but making the ylid can come up, especially in a synthesis if you want to do it. Okay, and so I hope these 2 videos have been helpful, and I will see you in the next one where we will cover specific examples with the Wittig reaction that could be challenging.